Flippin' Physics.
Good morning, everybody, and welcome to my AP Physics 101 Live Kahoot Multiple Choice Review. This is for all the units, and this is to review for the AP exam, which is 8 days away. Please sign up for the Kahoot. You can see all the information you need to sign up for the Kahoot right there. So I can see that people are doing that. That's wonderful. So this is so just be aware that there is another Kahoot 1 week from today. It is an exclusive Kahoot for my Ultimate Exam Slayer students. It will be very similar to this one in that it will be 14 multiple choice questions, which review the entire curriculum or cover the entire curriculum. And they will be completely different than the 14 we're going to do today. So just be aware if you'd like another review, another Kahoot review like this, it's going to be 1 week from today, Tuesday, May 5th at 7 p.m. Eastern Time. That's right, the day before the exam. So I would be remiss if I did not discuss these three items right here: the Ultimate Exam Slayer, Flipping Physics, and Ultimate Review Pack. I am, of course, Mr. P from Flipping Physics. I have all sorts of physics videos for you. I believe there are more than 40, I think it's like 45 hours now of AP Physics 1 videos that you can enjoy and learn physics from me about AP Physics 1. Be aware as well that I do have everything on my Flipping Physics YouTube channel is free. I've kept that way for, it's been 13 and a half years now. I do also have my Ultimate Exam Slayer and Ultimate Review Packet. The Ultimate Exam Slayer is specifically for studying for the test itself. So it goes through, has information about the 4 different types of free response questions and how to study for those and what they all mean. I go through the multiple choice types of multiple choice questions. I went through and created categories of multiple choice questions. I talk about how the exam works. I have multiple choice quizzes for each one for each unit. I have some tips and strategies. And I have 2 practice AP Physics 1 exams that are in there as well. And they use our digital exam testing software, which mirrors the AP College Board Blue Book testing software, but is neither endorsed nor created. It's different. Anyway, that's the Ultimate Exam Slayer. Ultimate Review Packet is more centered on understanding the material. There's all sorts of stuff in there, study guides, common stumbling blocks, things like that. And there is 1 practice exam in the Ultimate Review Packet. And again, everything uses our AP testing software. Okay. So here we go. Let's a few items before we begin the Kahoot as everyone is signing in. Be aware that section 1 of the AP Physics exams all have 40 multiple choice questions, and you have 80 minutes to complete those 40 multiple choice questions. If you do your math, you can see that that is 2 minutes per multiple choice question. So today in this Kahoot, you're going to have 2 minutes per multiple choice question. So this is to give you a good feel for what 2 minutes is like. Be aware that on the exam, of course, you can take more time on some questions and less time on other questions. But we're not going to do that today. Today, the idea is just to get a good feel for what 2 minutes per multiple choice question means. Please take a moment to say hello to Miss Bonk. She is our moderator for today. Miss Bonk is an AP Physics and Project Lead the Way teacher at Addison Trail High School, which is west of Chicago. I'm sure it's called a suburb of Chicago, but it seems to be pretty far west of Chicago. So Miss Bonk is there in the comment section to help you guys with any tech support questions that you may have, maybe answer some physics questions, because I don't think I will be able to answer them all today. Oh, all right. So actually, as long as people are still signing up, we'll actually go here. I will put this on here. Dino Man 109. I generally don't know where to start studying. There's so much I don't know and so little time to know how to do it. Honestly, you can, of course, use all of my free videos. I've got all my AP Physics 1 free review videos on my AP Physics 1 review video website. That's a great place to start, just by reviewing all of those. If you really are looking for more, I do suggest my Ultimate Review Packet. If you're looking for the subject matter, I would just start at the beginning and go through and do your best to understand the material from there. And if you're working for the exam, definitely my Ultimate Exam Slayer. All right, we still have a bunch of people that are signing up. I'll drink some water. I love this. Okay, I'm sorry. I'm going to put this one on here. 2 a.m. and still studying. Greetings from Turkey. Well, thank you. Welcome. I'm glad you're here. I'm sorry you're still studying at 2 a.m. That's, I'm glad you're doing it. I'm sorry you feel that you have to, I guess is how I'll say that. All right. So, I have some things I need to do in order to transition from this screen, which is my intro screen, to the actual quiz. So let's do that now while people are still logging in. So actually I'll go here, press that button, make it full screen again. That was my wife, by the way. Here you can see it's my wife in the rain with an umbrella. Okay, that's the Kahoot. So here we go. We put that to the left. We put that to the left. And this goes over here. So we have the quiz here, and what this is going to be the presentation about the quiz. And then this is the quiz here. And then we have all these people who are still signing in. It is weird that we have more people today than normal. Just be aware that I actually have been doing these. I've done 8 of these, 1 per unit all year. So I've already done 8 of these. This is my 9th. I guess encourage your friends who are taking AP Physics 1 next year to join those Kahoots, which happened earlier in the year. They are very helpful as well. Okay, we'll do this. Yes, I'm fully aware it's because the exam is coming up. But here's the thing. The more you study throughout the year, the better you'll feel right now, the more you'll understand right now, and the less frantic you'll feel. Just throwing it out there, because I am, of course, a teacher, and I can't not suggest that. I will not be showing you an image of the equation sheet, but be aware on the exam, you will actually have a physical paper copy of the equation sheet. Right now, I would take a few moments, maybe Ms. Bonk, if you could put the link in there for the equation sheet for AP Physics 1, that'd be lovely. But no, I'm not going to be showing, I don't have space on the screen here to show the equation sheet. Right. Oh, wow, we still have people joining. I guess I'll keep waiting a few moments. Okay, we'll put this one on here. Okay, so you're an AP Physics 1 first year teacher, an AP Physics, I'm assuming it's AP Physics 1, first year teacher. Thank you for telling your students to come to this. I'm glad you're here, but please handicap yourself quite a bit. Like, I'd love for it to have really just students answering the questions. So maybe as the teacher, you just hold off and don't answer the questions, because it would be great if the students could compete against one another. Wow, people still joining. I'm going to wait. I'm going to give it. Oh, I mean, we're almost 10 minutes past. Come on, people. No, wait. Do we have another person? We have another person from Turkey. That's awesome. The Kahoot code. The Kahoot code is right up there, and also it's in the chat. You'll see there's several people. Miss Bonks put it in the chat. Okay, we're 10 minutes past, so I'm gonna start because darn it, and people can join after we get started, but it is time to get started. Here we go. All right. It's going to do this whole flipping physics thing. I'm sure there's some sound, but I don't like the sound. So welcome to my AP Physics 1 review. There's the first question. You can see it coming. You can see it coming. And the first question, we are away. Good luck, everybody. 2 minutes. All right, the correct answer is choice C, and you can see we have more people answer choice C than in the other answers. Before we walk through why that is, we'll talk about this one right here. So, what are your best recommendations for studying for the exam? Should we review the units and then do practice tests, or do you have other tips? I have your review guide. Okay, so honestly, this depending on how solid you're feeling, if you have a particular unit that you're not feeling good at, in my ultimate review packet, you could go through the multiple choice quiz for the ultimate review packet. You could also go through all the study guides in the ultimate review packet, watch the common stumbling blocks. Another good thing to do is in the ultimate exam slayer, you could start by looking through all the stuff that has to do with the exam specifically, like what the free response question types are and all of that. And then do the first practice exam. And when you do the first practice exam from the multiple choice, you'll actually get a printout or a screenshot that shows you which of the units you struggled most with, and then you can go through and concentrate on those units. And then you can use the ultimate exam slayer to concentrate on those units and then take the second practice exam. So just throwing it out there. Okay, here we go. Question 1. We're trying to figure out why the correct answer was choice C. Here we go. Question 1. Looks like that. The slope of a position versus time curve is velocity. In this problem, we are solving for impulse. So we have 3 different equations for impulse. Impulse is equal to the average force of impact times change in time. It is equal to the change in linear momentum, and it is equal to the area under, quote unquote, a force versus time curve. Class. Which impulse equation do we use for this problem? Anytime I put the word class in there and there's a question, I'm asking you, my current class, all of you, to respond in the comments to tell me which of those 3 impulse equations do we use for this problem. All right. We have a bunch of people are answering. We're going to actually start here. Ba-ba-ba-bum. Pete, please do not disregard the delta. This is a common issue I see with students. You just ignore the delta. That delta means change in, it means final minus initial. Please remember the delta. So it is change in momentum. So we are using change in impulse equals change in momentum in this problem. Okay, here we go. Impulse equals change in momentum. So momentum final minus momentum initial. We can substitute in mass times velocity for both of those. And the mass of the object does not change. So that doesn't need a subscript. So it's mass times velocity final minus mass times velocity initial. So we could draw two best fit lines through the data to find the initial and final velocities, right? We're going to have a slope here and a slope here. Both of those are going to be velocities. This slope is going to be our initial velocity, and this slope is going to be our final velocity. So for the initial best fit line, our 2 points are 0 seconds and 2 meters. And our final point is at 1.25 seconds and 4.5 meters. We're just estimating those. It's fine. So the slope then, change y or change in x. So the initial slope works out when you plug in all the numbers to be 2 meters per second. And as we discussed, that's going to be the initial velocity of the object. For the final best fit, our 2 points are, again, 1.25 seconds and 4.5 meters. But then our final point here is 2 seconds and 1.5 meters. So we can, again, go through and figure out our slope. We get negative 4 meters per second. That is our final velocity. So we have impulse equals mass. We've already have this equation. We have the mass from the problem. So we substituted in 0.15 for the mass and negative 4 for the final velocity and 2 for the initial velocity. We get negative 0.9 Newton seconds. The question asks for the magnitude, so we can ignore the negative, and the correct answer is C, just so you know. If you accidentally use a positive slope for the final velocity, you get the incorrect answer of 0.3 Newton seconds, which is incorrect answer choice A. So please be aware of this. The writers of the AP exams know common students' mistakes, and they will put in answers that match your common student mistakes. So please be very careful when you walk through and you solve the problems. It's just that it's so important to be careful. And please don't ignore negatives and don't ignore delta. We already talked about that one. Okay. So that was question 1. Let's see how everybody's doing before we move on to question 2. Here we go. Happy Llama in first. We have Noble Ferret, so on and so forth. Zanny Ocelot. Okay. So moving on to question 2. Question 2 looks like this. And next. All right, look at that. Choice D. A lot of people got choice D. That's the correct one. Perfect. I just want to address a couple things. You are absolutely welcome for all the videos. That's why I'm here. Try to help you learn physics. I'm glad that they helped a lot. We do want to do this. Remember to be in degrees, everyone. Yeah, this is a good thing to remember. The only time you're not going to be in degrees, and I've rarely seen it on AP Physics 1, is when you're using, in simple harmonic motion, using the sine and cosine equations for simple harmonic motion. And I do see this a lot, a lot when people go from calculus to physics. They forget to change their calculator from radians to degrees because most often in physics we are in degrees. Okay, here we go. Let's see why choice D is the correct answer for question 2. All right, so question 2. Notice the structure of each of the answer choices. So this is an important thing to recognize about some of the AP Physics multiple choice questions. So there is an answer and then a reason, right? So the minimum speed of the projectile is either 0 or the speed over 2. So that's the answer, right? We have only 2 answer choices, but then we have a reason. And the reason has to do with the acceleration of the object in either the X or the Y direction. So it's good to just kind of see that as a structure for a question. You're going to see that type of structure of a question probably on the exam. So we have a projectile is moving at its minimum speed at the top of its path, right? So the speed that it's when it's at the top of its path is moving at its minimum speed. So the speed of the projectile at the top of its path is not 0. Please remember that. The speed of a projectile in the y direction at the top of its path is 0. So we now know that the correct answer is not 0. So the correct answer is v over 2. So the correct answer is either what, C or D. So we also know the acceleration of projectile is 0 in the x direction. So the correct answer is answer choice D. So notice, in this problem, you don't actually have to figure out that it's v over 2. You just have to figure out that it's not 0. And the only other choice is that speed over 2. I am, of course, going to walk through that anyway, because my job right here is to help you understand this stuff. And so that's part of understanding. So here we go. We have our initial velocity, which is v at this angle theta. So we have the velocity in the y direction, velocity in the x direction. Cosine of theta equals adjacent over hypotenuse. So the velocity in the x direction over the velocity is equal to the cosine of theta. So the velocity in the x direction, when we solve this, is equal to that speed v times the cosine of the initial launch angle, which is theta. So v cosine theta is the cosine of theta is, or 60 degrees, excuse me, is 1/2. So it ends up being v over 2. Again, you didn't have to do that to solve and understand this solution. But again, I'm just trying to help you understand physics. So there we go. All right, moving on to question 3. Before we do, of course, we're going to see how people are doing. Noble Ferret, congratulations. Happy Llama, congratulations on being near the top. All right, moving on to question 3. All right, that all fits. Perfect. All right. The correct answer is choice B. And we have more people answering choice B than anything else. That always makes me happy. Here we go. Look, figure out why choice B is the correct answer. So we have our question there. Question 3. So we're going to categorize the answer choices. Again, always a good idea to do that. So there are either one or two upward forces, and the magnitude of the total upward force is either equal to the magnitude of the downward force or equal to 2 times the magnitude of the downward force, right? So it's good to just kind of categorize. You can see these are equal in magnitude, and this one is roughly 2 times this one. And you can see this, the total magnitude of the upward force is roughly twice the downward force. And here you can see the total magnitude of upward force is about equal to the downward force, magnitude of the downward force. Great. So we're going to isolate the object we are drawing the free body diagram of. It is pulley 1. So it's easier to see how this works when we look at pulley 1. So there is one downward force from this rope, and there are 2 upward forces, one from each of those ropes. So if the net force equals 0, A is correct. If the net force equals a positive number, B is correct. We need to know if the net force is 0 or positive. So it says in the problem, the box is accelerating upward. So the net force and therefore acceleration are both positive. So the correct answer is choice B. Great. All right, moving on to question 4. Before we move on to question 4, of course, let's see how people are doing. Yeah, there's going to be a lot of shaking up at the top here, I have this feeling. Okay. Moving on to question 4. There we go. Question 4. All right, choice B. Again, we're doing well. I love it. Okay, so I do want to go over some comments we've gotten. So this was about the previous question. Why is it not D? Also about the previous question. Why not D? Also about the previous question. It's asking for the free body diagram of the pulley, not the box, which is the answer as to why it's not D, which brings us to this, which is reading is fundamental. Yes. If you ever talk to an AP physics teacher about what their biggest suggestion is to read the question. Please slow down, read the question, read the whole question. That'll help you to remember that it is accelerating upwards, for example. Please remember to read the question. All right, let's figure out why B is the correct answer. for question 4. Here we go. In question 4, we already have the free body diagram. Now we just need to sum the forces. Class, why is this an incorrect statement? I want to know what is wrong about what I just said. Why why can't we just sum the forces? I mean, we already have the free body diagram. Here we go. We have a lot of people answering, and we've got some. Aha! Here we go. Let's do right. Oh, nope, that's not the one I'm doing. Here's the one. Okay, so the free body diagram we drew in question 3 was for the pulley, not the box. Question 4 is about the box. Again, it all comes down to reading carefully, please. So this is an incorrect statement because we don't have the free body diagram for the forces acting on the box. We have the free body diagram for the forces acting on the pulley. Please, again, read carefully. Here we go. So the free body diagram, I just said all that. Okay, so the free body diagram for the box. The force of tension is upward, the force of gravity is downward. So we're going to sum the forces on the box in the y direction. The force of tension up positive, force of gravity down negative. That's equal to mass times the acceleration in the y direction. So the force of tension, we can bring mass times the acceleration in the y direction over to the other, or sorry, force of gravity over to the other side. We get force of tension equals the force of gravity plus the mass times the acceleration in the y direction. We know, again, the acceleration of the box is upward and positive. So this value is positive, which means the force of tension is greater than the force of gravity. The correct answer is choice B. Great. Right. So we just walked right through that. So answer choice A is incorrect. So this is important to recognize. So realize answer choice A, the force of tension could be greater than 2 times the force of gravity. But we don't know that to be true. It could be true, right? But we know the force of tension is greater than the force of gravity. We know that to be true. So I think I heard somebody leaning towards this one, asking about, do we know anything about this? We don't know enough about this question to be able to say that it's greater than 2 times the force of gravity, but we do know it's enough to be able to say the force of tension is greater than force of gravity. So that's something to be careful of. Sometimes they give you an option which could be true, but you don't know it to be true from the question statement. Just got to be careful of that. Okay, question 5. Before we move on to question 5, we have the scoreboard. Ooh, we didn't have any changes. Interesting. Moving on to question 5. Here we go. Good luck. Ooh. So answer choice D is the correct one, but we had more people answer choice A than D. Interesting. We will see why that is, perhaps. I did want to talk about this question. So, what happens if I get a question wrong? My assumption is that you're referring to a multiple choice question, and it is important to know that if you get a multiple choice question wrong, you lose no points. There is no penalty for getting a multiple choice question wrong. So, the worst thing you could do on this exam is to leave a multiple choice question blank. So, please make sure to answer every multiple choice question, even if you're just flat out guessing. Please. All right. So, let's figure out why choice D is correct, and yet a lot of people answer choice A. We'll figure it out. All right. So, question 5. Okay. So let's just talk a minute about what we know about the answer choices. We know the system is always the brick earth system. So sometimes in these questions, the system changes, which can really change things. So realize in all of these answer choices, the brick earth system, the brick and earth is the system, which is helpful. So there are in the questions total mechanical energy, kinetic energy, and work in the answers, right? So let's just talk for a minute about what we know about what happens here. So the force of gravity on the brick is down. The force the person applies on the brick is up. So the displacement of the brick is down. These are all things we know. So the person does negative work on the brick. The way that works is the force applied is up and the displacement of the brick is down. So this person is doing negative work on the brick. I'm sorry, on the brick earth system, because the cosine of 180 degrees is -1. So realize the person does negative work on the brick earth system. So the brick, we also know the brick moves at a constant velocity, right? It says that in the problem, the brick is moving at a constant velocity. So in choice A, the person does negative work on the brick. Answer choice A is incorrect because it's right. So choice B, the gravitational potential energy of the brick earth system decreases as the block goes down. So answer choice B is incorrect. In choice C, the mass and speed of the brick are constant, so the kinetic energy of the brick remains constant. So answer choice C is incorrect. So choice D, we know the total mechanical energy equals the kinetic energy plus the gravitational potential energy. We know the kinetic energy is constant, and the gravitational potential energy decreases. So the total mechanical energy decreases. The person does negative work on the brick. So answer choice D is correct. Great. All right, before we move on to question 6, we of course see how everybody is doing. Ooh, no shaking up. All right, moving on to question 6. All right, choice B. A lot of people got that one correct. We'll talk about that in a second. Clearly, we need to talk a little bit more about this. All right, we'll do this one. This is all about the previous question. Isn't the force of gravity and displacement down so theta equals zero? That would be for the work done by the force of gravity, yes. But we were talking about the work done by the force done by the person, which is the force applied. The force applied was up. So you got to be careful. The work is always done by a particular force or the net force, which would be the network. So you got to be careful of that. Okay, so how is the force up if the person is lowering it straight down? Okay, so we have my phone. In the absence of any other force, if in the absence of me holding the phone, my phone is going to fall. My phone will accelerate downwards, right? So in order for me to keep the phone moving downward at a constant velocity, I have to apply a force upward to counteract the force of gravity, which would accelerate it downward if that were the only force. So my force has to be applied upward to keep I don't know what it was, but my phone moving at a constant velocity. So that's how you know the force applied is up. And that force applied does negative work on the phone Earth system in this particular case. And with that negative work is removing energy from the system, right? It's moving at a constant velocity. In the absence of the force applied, my phone would accelerate downward and the kinetic energy would increase, but it is moving at a constant velocity, so the kinetic energy is staying the same. So as I lower it down, I'm doing negative work on the system because I'm literally removing kinetic energy from the system. There you go. All right. Actually, somebody else had a question. Somebody had a question about, here it is. Can we use calculus in an AP Physics 1 free response question? The answer is yes. But the answer is also you have to be very careful because you have to show all of your work. And historically, my AP Physics 1 students who also know calculus are actually very terrible at showing their calculus work on AP Physics 1 free response questions. So with that caveat, the answer is yes, but I actually do not suggest it because you do not need calculus to solve any of them. And historically, y'all are not good at showing your calculus work in physics. As somebody who taught AP Physics Mechanics, AP Physics C Mechanics and E&M, I know that to be true. Please. Sorry. Okay. I'll get off my high horse. Here we go. Question 6. So answer choice B. A lot of people got it right. So here we go. Question 6. All right. Oh yeah, this one. I love this one. Okay. So there's no real structure to the answer choices. So sometimes it's just going to be a whole bunch of random stuff. So each answer choice is independent from the other. Sometimes that's going to be the case. So choice A, if the projectile is moving to the right, the drag force is to the left. So this will slow the projectile down. However, it does not cause the projectile to accelerate in the y direction. It only causes an acceleration in the x direction. So answer choice A is incorrect. It is not the drag force that causes this to happen. So choice B, the force of gravity on the projectile causes it to accelerate in the y direction. That is a true statement, right? The force of gravity is down, so it's going to cause the projectile to accelerate in the y direction. So that is true. So answer choice B is correct. Answer choice C is just, I took a bunch of physics words and I shoved them all together into a sentence, and that doesn't really make any sense. And you'll see that on the exam. You're welcome. So choice D is incorrect. Just look at answer choice B and you'll see why that is false. All right, so question 7. Before we do look at question 7, let's see how everybody's doing. Happy llama. Interesting. Okay. Moving on to question 7. Here we go. Good luck. All right, question 7. We got a lot of people answered choice C, which is correct. So let's figure out why. Question 7. So this is a straightforward rolling without slipping problem. The equation for the velocity of the center of mass of an object rolling without slipping is not on the AP Physics 1 equation sheet. Now, I know a lot of you are going to tell me that it is, but please be aware, this equation, the velocity of the center of mass equals the radius of the object times the angular velocity of the object, is not on the equation sheet. It's subtle but important. It almost is. The V equals R omega is on the equation sheet, for that literally stands for tangential velocity equals radius times angular velocity. So realize it's sort of there, and you need to be able to recognize that those two equations are very similar, and it's fine if you read this as the velocity of center mass equals the radius of the object times the angular velocity of the object. But technically, this equation is for the tangential velocity of the object, which equals the radius of the location on the object that you're talking about the tangential velocity of times the angular velocity of the object. Subtle distinction, but it's important to recognize that you can clearly get it from there. So we can set that equation equal to the equation for average velocity. So the velocity of the center mass equals the radius of the object times the angular velocity of the object. So the x center of mass, the change in position of the center of mass over the change in time, is the equation for average velocity. We can solve for the change in position of the center mass. It's going to be equal to the radius times the angular velocity of the object times the change in time. So that is obviously answer choice C, which is correct. And an interesting thing to notice about this is that answer choice C is the only answer choice with the correct units. Sometimes you can actually identify the correct answer from the units, or at least narrow it down a bit. So just be aware of that. It's good to look at units sometimes. So just to look at the units, the radius is in SI units of meters. Angular velocity is going to be SI units radius per second, and time SI units of seconds. So seconds cancel out. We have meters times radians, and radians are a unitless dimension, so it just ends up being equal to meters. So just be aware of that. All right, moving on to question 8, and let's see how everybody's doing. Oh, lucky ladybug took the lead. All right, let's see. Question 8. Here we go. All right, answer choice B is the correct answer choice. We'll talk about that in a minute. Let's just answer this question. So I'm not going to do something similar for AP Physics C Mechanics, or AP Physics C Electricity and Magnetism, or AP Physics 2. I'm sorry. This all takes a lot of time for me to prepare and walk my way through and all that stuff, and I just don't have time to do it for all of the AP Physics exam. Sorry, there are four of them. I have time to do it for AP Physics 1. So I'm really sorry. I wish I had more time. All right, let's figure out why that is the correct answer. Moving on to question 8. All right, here we go. So class, what forces are acting on the block at position 4 and what are their directions? So again, class, I'm asking you to answer the question. What forces are acting on the block at position 4 and what are their directions? Not just, I want to know what are the names of the forces. So I'm looking for the name of the force and their forces and their directions. Oh, I love this. Okay. We're gonna do this one. Force of gravity and centripetal force. First off, you didn't say any directions. Second of all, centripetal force is not a new force. It's not a force that acts on an object. It is the net force in the indirection. So centripetal force is not going to be the answer to this question. Please. Let's do. It's not centripetal force and it's not gravity. Please. Oh. We're so close. I love this one. Okay. Normal to the right, gravity down. First off, normal without the word force just means perpendicular. So please, you got to add the word force. Plus, you just said gravity. There's no such thing as just gravity. Please never use the term just gravity on an AP physics exam. It is the force of gravity. Or is it the acceleration due to gravity? Or is it the gravitational potential energy? There are so many different types of gravity. You have to specify. So the correct answer is normal force to the right. I'm going to find one that says force of gravity. Darn it. Here we go. Normal force radially inwards, which is to the right, and gravitational force down. So radially inwards is the same. So there you go. So those are our two forces. So we have the force normal, which is inward or to the right at position 4, and the force of gravity, which is downward. So there is no force of friction, it says in the problem. So there's no force of friction. So it looks like this. That force normal acts inward. That force of gravity is straight down. So the net force is down and to the right. So the correct answer is choice B. Wonderful. Moving on to question 9. Before we do, of course. Oh, I'm sorry, lucky ladybug. That must be rough. All right. Moving on to question 9. All right, look at that. A lot of people answered choice C. I love it. Okay, let me answer a couple questions here. This is about the previous question. I thought net force is always pointed towards the center because it is in uniform circular motion. And the answer is, if it were in uniform circular motion, the answer would be yes. But in that problem, it is not uniform circular motion. The angular acceleration of the object was not zero. The angular velocity of the object was not constant. So because in fact, it's not, because the net force is not pointed towards the center. So realize it was not uniform circular motion. Yeah, that's all I got. Okay, let's figure out why choice C is the correct answer here for this question. All right, here we go. Question 9. So the graph has a constant slope. Class, what is the slope of an angular velocity as a function of time graph? So again, class, is a question for you. What is the slope of an angular velocity as a function of time graph? Ooh, I love it. I love it. Okay, so we have, I'm going to highlight this one first. Wow, where'd it go? Oh. There it is. Oh. Got to be careful. It's not acceleration. It is instead angular acceleration. I want to see if anybody said fishy thing. Anybody say fishy thing? Fishy! There we go. Thank you, Tina Coco. Tina Coco. Fishy thing. Sorry, I call it fishy thing in a lot of my videos because it looks like a fish. So, sorry. So I was distracted. So the slope of an angular velocity as a function of time graph is angular acceleration, lovingly called fishy thing. All right, so here we go. So angular acceleration. So the angular acceleration of this object is constant. So choice A has to do with net torque. So net torque equals rotational inertia times angular acceleration. So the net torque is constant, right? Because the angular acceleration is constant and the rotational inertia of the disk does not change. So answer choice A is incorrect. Choice B has to do with angular momentum. So angular momentum of a rigid object equals the rotational inertia times angular velocity. So angular velocity is changing, so angular momentum is changing. So answer choice B is incorrect. Choice C has to do with rotational kinetic energy. Rotational kinetic energy equals 1/2 times the rotational inertia times angular velocity squared. So rotational inertia is constant. The angular velocity is increasing, so the rotational kinetic energy is increasing. So answer choice C is correct. Answer choice D, uniform solid disk has a constant rotational inertia, so answer choice D is incorrect. Moving on to question 10. Before we move on to question 10, we're going to see how everybody's doing. A little bit of shakeup, not much. And we have question 10. Looks like this. All right. Choice D. Oh, this is fun. Okay. Choice D is the correct answer. And the least number of people answered choice D. This will be fun. I look forward to going through this solution with you. All right. I do want to answer a couple of things. Here we go. Captain Jack is a great speaker. I'll never see the fish. I'm sorry you will never see this fish. But I'm glad you are here. Do you have to memorize rotational inertia equations? No. Please do not memorize the rotational inertia equations. If you need the equation for rotational inertia, it will be given in the problem. I do recommend maybe memorizing the relationships between them, like the rotational inertia of a solid cylinder is less than rotational inertia of a thin hoop, right? So you can go through and do those things. And that it should be obvious from the fact that the further the mass is concentrated from the axis of rotation, the higher the rotational inertia, but do not memorize them. There was one more. Oh, here. Do I think it is better to work on free response questions problems or multiple choice question problems? No, is my answer to that question. Just no. Honestly, you got to work on both. You have to work on both. It's just the reality. You got to be able to do both. So, no, I don't suggest one over the other. All right. Moving on. Question 10. Let's figure out. Oh, that's right. So we get to figure out why D is the correct answer choice. This is going to be fun. All right. So we have this graph. All right. Hooke's law says that the force of the spring is equal to the negative of the spring constant times the displacement from equilibrium position. We also have the equation for the y-intercept form of a line, which is y equals slope times x plus b. I avoid using m for slope in physics because, mass is going to be confusing for people. So the slope of the line is the negative of the spring constant. You can see that this right here, the negative of the spring constant, is the slope of the line. So the best fit line for these data passes through 0.2 meters and 60 newtons, and 0.7 meters and 10 newtons, right? So we can figure out the slope, which equals negative the spring constant. You can figure out that the negative the spring constant equals negative 100 newtons per meter. Therefore, the spring constant equals 100 newtons per meter. So from the graph, so far, we have figured out the spring constant. Now, the forces on the mass at rest when it's rest hanging on the vertical spring, right? These are the forces, the free body diagram, essentially. We have the upward spring force and the downward force of gravity. Those are the two forces. It's at rest. So some of the forces in the y direction, force of spring is up, positive, force of gravity is down, negative. We know the acceleration of the y direction equals 0 because it's at rest. So therefore, we know that the force of the spring, the magnitude of the force of the spring equals the magnitude of the force of gravity. The magnitude of the force of the spring equation is the spring constant times the displacement from equilibrium position. The magnitude of the force of gravity equation is the mass of the object times gravitational field strength. We can set those to equal to one another because we know that the magnitudes of those two forces are equal. We can then solve for the displacement from equilibrium position. We get mass times the acceleration of gravity times the spring constant. Now, 2 times 10. Now, I do want to recommend you always use 10 for gravitational field strength for the acceleration of gravity here on planet Earth on the AP physics exams, right? You will still get the right answers if you use 9.81, but just to make all the math easier, you can use 10. Please use 10. So 2 times 10 divided by 100 is 0.2 meters. Now, you might think that 0.2 meters then is the answer to the question. But 0.2 meters is not the answer to the question asked. So this is the displacement from equilibrium position. And the question here is which of the following best approximates the new length of the spring, which is not the displacement from equilibrium position. So 0.2 meters, again, the distance from equilibrium position, not the new spring length. So the new length of the spring is the natural length of the spring plus the displacement of the spring from equilibrium position, or 0.2 meters. So we need the natural length of the spring. So class, where do we find the natural length of the spring in this problem? Class, I want to know, where do we find the natural length of the spring in this problem? All right, we have a lot of people answer this question correctly. So we'll just do, it's hard to, they keep moving when I try to click on them. Okay, there we go. So it is the x-intercept of the graph. It is, there's another place. So I like this. So when the spring force is equal to 0, just to make sure we're identifying that, that is the spring force. So when, yeah, here we go. When the force on the spring is equal to 0. So if you follow this line, it goes all the way down to right here. You can see that is roughly 0.8 meters. So here we go. The natural length of the spring is the x-intercept of the best fit line, or 0.8 meters, where the force of the spring is equal to 0. This is because, again, the natural length of the spring is when there's no force acting on it. So the new spring length is the 0.8 meters plus the 0.2 meters, or 1 meter. The correct answer is D. Awesome. I love that. Okay, so that was question 11. Let's see, or no, that was question 10. Let's see how everybody's doing. Oh, happy llama. Okay, invincible flamingo. Good luck. All right, moving on to question 11, which looks like this. Question 11. All right, look at that. We went from what happened on the last one to this one. That was kind of intentional. Okay, so I just here, just let's just do this one. Actually, let's do this one. Resources for practice multiple choice questions and free response questions. I don't know how else to say it. My ultimate exam slayer is right there for you. I have so many practice multiple choice questions and free response questions, and I have all of my solutions. Like the stuff that I'm walking through in here is exactly the type of thing that I have in my ultimate exam slayer and ultimate review packet, where every question I give detailed solutions for them. So please invest in them. They will really help you out. All right, let's figure out why choice C is the correct answer, even though many of you got it right. Let's figure it out. All right, so here we go. Question 11. The slope of an angular position as a function of a time graph is angular velocity. There are two constant angular velocities shown in the graph. So, right, and then it's transition occurring right in the middle. So something happens in the middle to increase the angular velocity of the skater. So choice A, there's nothing in the problem which could cause a net external toik. Yeah, that's definitely it, toik. So answer choice A is incorrect. So their rotational inertia is changing. And the second half of the statement is correct, but the whole statement needs to be correct. So choice B, the skater brings in their arms. This decreases the rotational inertia. However, because there is zero net external torque, the angular momentum of the skater remains constant. So answer choice B is incorrect. Choice C, the skater reduces their rotational inertia. Yes, this is true. Causing their angular velocity to increase. Yes, also true. While conserving angular momentum. Yes. Everything in questions in answer choice C is correct. So answer choice C is correct. In choice D, the rotational kinetic energy, 1/2 rotational inertia times angular speed squared. So their rotational inertia decreases. So, and their angular velocity increases. So the skater's rotational kinetic energy does not remain constant. It changes clearly. So answer choice D is incorrect. Woo! Yes. Question 12 will also have a graph, and that's 4 questions in a row with graphs. You are welcome. Let's see how everybody's doing. My assumption is we're not going to have a whole lot of shakeup. Yeah, kind of figured. Okay, here we go. Question 12. Only 3 left. Good luck, everybody. All right, answer choice B. We have a lot of people answer choice B. That's great. Let's do. I want to answer a couple questions here. We'll start with this one. Are sig figs very important? So on the AP exam, sig figs are not really that important, but to that end, if you give an answer that's like 0.12757776321, you could lose a point for sig figs just because that's just obnoxious. So just like leave it at 2 or 3 sig figs and you should be fine. I will point out that every number answer you give does need to have units on it. So please make sure all of your number answers have units on it. What's the best way to handle a lab-based free response question? So literally, I have I think it's like a 16 or 17 minute video in my Ultimate Exam Slayer that goes through and talks about exactly this. Like I've spent more than 1,000, maybe 1,500 hours creating my Ultimate Exam Slayer and Ultimate Review Packet. Like I go through and answer questions like this, but I'm not going to take the time to do that here because I can't do it. I know you're probably sick of my suggesting those, but really, please, I've suggested them because I've spent so much time on them. Okay. Anyway, let's see why choice B is correct. So here we go. So a cylindrical tank of water, right. Okay. So here we go. The equation for gauge pressure is that gauge pressure equals rho times G times H. Class, what is H in this equation in this problem specifically? So class, I'm asking you, what is lowercase h in this equation in this problem specifically? Okay, I'm gonna put some in here. We'll answer. So, no, it's not 2 meters. Fun. No, it's not 5. Depth of 5. No, it's not height. It is. Here we go. Distance from the hole to the top of the water slash depth. So it is important to recognize it is the distance from the hole to the top of the water. It is not a single number. Wait, is it H? So realize it is the vertical depth of the water from the top of the water to the location where the gauge pressure is measured, right? It's going to be this distance right here. But because the water level is lowering the whole time, h is not a constant number. Lowercase h is not a constant number. So lowercase h in this particular problem is equal to uppercase h, the total height, minus 2. But this total height h is also a variable. So capital H changes and lowercase h changes. Okay. So please recognize this question does not have to do with Torricelli's theorem, which gives you v, the speed of the water out of the hole. This question looks a lot like a Torricelli's theorem question because you've seen several questions like this, but it's not about Torricelli's theorem. So gauge pressure, please realize gauge pressure is not measured just outside the hole, but rather just inside the hole at the height of the hole. Okay, so again, recognize capital H is a variable. It starts at 5 meters and capital H ends at 2 meters. So the gauge pressure then, if we substitute in lowercase h equals uppercase h minus 2, we get this equation right here. The gauge pressure equals the fluid density times the gravitational field strength times capital H, which is the full height, and that decreases over time, minus 2 times, again, the fluid density times gravitational field strength. So again, we have the y equals slope times x plus y-intercept plus b on, we have the slope-intercept form of a line. So from here, you can see on the y-axis is gauge pressure, right? Gauge pressure on the y-axis. The slope is equal to the fluid density times gravitational field strength. And on the x-axis is capital H, this water depth. And the y-intercept is -2 rho g, right? So realize the graph is a line with a constant positive slope and a negative value for the y-intercept. The only graph that matches that is correct answer choice B. So realize we never used the 2 numbers given in this problem to solve this problem. That's going to happen sometimes on the AP exams. So don't feel stressed if you didn't use a number. It's okay. So another interesting thing about this graph is that it is counterintuitive because time, which is not on the graph, right? We have gauge pressure as a function of water depth. Time is not on the graph, but as you think about it as time goes by, it starts with the highest gauge pressure and the largest water depth. And as the depth of the water decreases, it actually goes this direction. So the time moves from right to left on this graph. So it's a very strange graph, but that's the reality. So neither of the axes are time. Neither of these axes are time. Neither are, whatever. So question 13. Before we move on to question 13, let's see. All right, Happy Llama, are you gonna hold it out the whole time? Or are you gonna hold off Invincible part? I can remove somebody? Not gonna do it. So Invincible Flamingo. Good luck. Moving on to question 13. Oh, I did use a number at this develop point. All right, answer choice C. The more people answered choice C than any other answer. That's fun. Let me see. Well, let's see why answer C is correct for 13. Here we go. Question 13. The period of a simple pendulum is on the equation sheet. Period equals 2 pi times the square root of the length of the pendulum, which is from the center of suspension to the center of mass of the pendulum, divided by gravitational field strength. The period of the first pendulum is just 2 pi times the square root of L over G, because we could just define L. L is defined as the length of the pendulum for the first one. For the second one, the length is defined as 1/4 over L. The square root of 1/4 is 1/2. This in parenthetically here is the period for the first pendulum, so we can substitute the period for the first pendulum in there. When we're figuring out the ratio of the two periods, we get the period 1 over period 2, so we get 1 over 1/2, which is 2. The correct answer is C, which does bring me to this. Blah, blah, blah. Where'd it go? Somebody said, yep. I forgot the ratio. Again, this comes down to reading carefully. Please always read carefully. It is so, so important. Yeah. All right. So we're done with question 13. Yes. Right. Question 14. All right. So let's see where we are with one question left. Okay. Interesting. Good luck to all of you. One question left. Question 14. Oh, rough. On this last question, we have only 30 people got it correct. We have to see why choice A is correct. I do have to just highlight this one though. Again, oh no, I forgot about friction. Oh, I don't know how many times I can say it. Read the question. It literally says in the question, the friction between the surfaces is not negligible. Yep. Please, just learn from this experience. Read carefully. Okay, here we go. Here we go. Question 14. Class, what piece of information is missing from the question? I'm curious what you're going to say to that. What piece of information is missing from the question? I guess I'll say something that I guess you would expect to be given in the question, but it's not. I'm not gonna. That's an interesting one. I'm going to try to click on this one. Boom. Which block is heavier? Doesn't matter. Massive block V, doesn't matter. Here you go. Which direction block U is moving? So the direction of the movement, the direction of the blocks is the direction the blocks are moving, right? So that is missing. So it's an important thing to recognize. They don't even need to tell you which direction the block is moving in order to answer this question. We'll talk about why. So we don't know which direction the two blocks are moving. So here are the options. Block V could be moving up the incline while block U is moving down the incline. V moving up, U moving down. Or it could be that block U is moving up the incline and block V is moving down the incline. Those are the two possibilities. So regardless of which direction blocks are moving, block U will have the following forces acting on it, right? So no matter which direction the blocks are moving, U will have a force of gravity straight down. Block U will have a force of tension up from the string up the incline, no matter which direction U is moving. They will have a force normal from the incline, which is up and perpendicular to the incline. And we'll have a force normal from block V down and perpendicular to the incline. So two force normals. It will have a force normal up and perpendicular to the incline caused by this surface. And block U will have a force normal down and perpendicular to the incline caused by the interaction with block V, that surface interaction. So it's going to have at least these forces. It's going to have one force that's straight down, one that is up the incline and parallel to the incline, one that is up and perpendicular to the incline, and one that is down and perpendicular to the incline. So from that, we know that it either is answer choice A or B. Great. So now we need to know how many forces act parallel to the incline. So next, we figured out everything else, but we need to figure out the forces that act parallel to the incline, and this depends on which direction the object is moving. So if block V is moving up the incline and block U is moving down the incline, block U will also have the following forces on it. So again, if block U is moving down the incline, it will have a force of kinetic friction on block U, which opposes the sliding motion of block U up the incline. So this is from the incline. There will be a force of kinetic friction up the incline because the block U is moving down the incline. There will also be a force of kinetic friction from block V on block U, which again opposes the sliding motion of block U, which will also be up the incline. So if U is moving down the incline, there are going to be two forces of kinetic friction, one up the incline from the incline, one up and parallel to the incline caused by the incline, and one up and parallel to the incline, which is caused by the interaction with block V. So if block U is moving up the incline and block V is moving down the incline, block U will have the following forces acting on it. So the force of kinetic friction on block U, which opposes the sliding motion of block U, again, block U is moving up the incline. So that force of kinetic friction from the incline is going to be down the incline because the block is moving up the incline. So it will also have a force of kinetic friction, which is also down the incline, which from block V, which again opposes the sliding motion of block U. So there are forces for the forces parallel to the incline. There are two possibilities. There's either three forces up the incline, or there's one force up the incline and two forces down the incline. So if you look at our free body diagrams, there's only one answer choice that matches that, and that is correct answer choice A. So we now know block V is moving up the incline and block U is moving down the incline. So just to walk through all of those forces, just so you can see this. So these are the forces acting on block U. We have the force normal, which is perpendicular to the incline and up, caused by the incline. We have the force normal, which is perpendicular to the incline and down, caused by the interaction with block V. We have the force of gravity straight down on block U. We have the force of tension in the middle here, which is caused by this string. And then we have the force of kinetic friction acting up the incline because U is moving down the incline. So that's the interaction between U and V. And we have the force of kinetic friction, which is also up the incline from the interaction between U and V, again, because U is moving down the incline. And we are done. Yeah, I'll do all this first. Okay, so we're done. So my plan is for this video to remain live on YouTube. I have no reason to take it down. So this multiple choice quiz will be posted in my Ultimate Exam Slayer in like 10 minutes. So I'm going to post this multiple choice quiz in my Ultimate Exam Slayer. For my Ultimate Exam Slayer students, be aware that I will be doing another 14 multiple choice quiz review 1 week from today, Tuesday, May 5th at 7 p.m. Eastern Time. That's for my Ultimate Exam Slayer students. So they're, again, different multiple choice questions, but they review all the topics. So realize if you already have my Ultimate Review Packet, there is a link to get the discount on my Ultimate Exam Slayer in the ultimate review packet. You need to look in the need more help section. Please make use of my 30-minute exam cram video, like day before, a couple days before the exam. It's a really good, just like review everything video. And before I read that, we're going to figure out who won. Here we go. Rapid Mantis in third. Happy Llama. Congratulations, Invincible Flamingo. You are truly invincible. All right, before I read this last thing, best of luck on no, it's not tomorrow. Sorry, it's not tomorrow. I apologize. But best of luck on whatever you're doing tomorrow. But really what I meant is best of luck a week from tomorrow, but whatever, it'll be fine. Before I read that, let me look through see if there are any questions I want to answer. Congratulations. Why is the force normal from block V coming down? Okay, so that's fair. So why is the force normal from block V coming down? Where's it going to be? Can I bring it here? So force normal from block V is, can I do it this way? No, whatever. So the force normal from block V is going down because block V is pushing down. That is the force normal from block V on U is pushing down on U. There's a force normal on V, which is up and perpendicular. So there's two force normals caused by the interaction between those two objects. I lost this. So I do want to play this. Boop. Then we're done. Okay. Let me see if there are any other questions I want to answer. Best of luck tomorrow still. Have your use, is there a thing? It's in my Ultimate Exam Slayer where I talk specifically. So the Ultimate Review Packet is about like the concepts and understanding the physics concepts, whereas the Ultimate Review Pack or Ultimate Exam Slayer, the Ultimate Exam Slayer is more about the test. So that information is going to be in my Ultimate Exam Slayer. All right. I think I've answered enough questions. I think it is time for us all to be done. So, ladies and gentle people, thank you very much for learning with me today. I enjoyed learning with you. Best of luck tomorrow on whatever you're doing. And best of luck in 8 days on the AP Physics exam. I look forward to seeing as many of you as possible 1 week from today with my Ultimate Exam Slayer review Kahoot. All right. Good night.
Flippin' Physics.